Okay, first point, specify the second one, and specify third one. Then here we have a spline. Okay, spline is a continuous curvature line. We can create the line with the help of points also, and we can set the degree also. Here we have this side spline. Here we can set the degree or Bezier curve. We can set the degree of that spline based on 573 we want. Then here we have rectangles. Based on their formation, we have a type here. From corner, if the rectangle is started, so this is my corner rectangle. From center, symmetrical rectangle we can create with the help of 3 points. We can create from the 3 center point we can create, and also parallelogram we can. So here we have a corner rectangle. Specify the first corner. See, 1, 2 means their input type, input form, input steps. So first corner, specify the first corner, specify the second corner. We can give parameters also, this center parameter. Also you can give coordinate and a parameter type input you can give. Coordinate type input means each on every coordinate, XY coordinate. And your parameter means, for example, for length, we can use a line, length, and angle. So such kind of parameter types also we can give here. Then here 3-point corner rectangle. Specify the first point of the starting point, second starting point, and third starting point. Then here we have a 3-point center rectangle. Specify the center of the rectangle, then second center and comma. And we have here parallelogram. Specify first point, second point, and third point. Then if you want to create an arc, for arc the input type is radius. So here we have 3 types of arc. The first one is center point arc. Center point arc means the starting point, the arc will start from the center. So go click on center, then specify the start point and specify end point. We can. Then here tangent. Tangent arc means your continue arc. Okay. If you want to create one tangency arc to this segment, line segment, so click here, tangent arc, click from which point you want to start, and we can. So my tangent arc, and from the end point also we can create one arc also from the end point. So this is my continue arc. You can say continue arc also. Then the last one is here 3-point arc. Start point, end point, you can give direction, or third point. Then here we have an ellipse. For ellipse, the parameter type is major axis, minor axis. If you are taking a half, semi-major, semi-minor. So here go to ellipse. Okay, specify the center point. Then half distance of first axis and half distance of other axis. See, the parameter type you can give. Center coordinate you can give. If you want to use as a construction, we can. Construction line. Okay. So then here we have an elliptical arc, partial ellipse. So if you want elliptical arc, so go to partial ellipse here. Okay, specify okay, specify center, then start half distance of first axis, half distance of other axis, and we can do from the starting angle and from the end angle. We can give here. Then yes, here we have a parabola. Okay, parabola have one focus point and one apex. Apex point means through that point parabola will pass. So specify the focus point and then apex and draw the parabola. Then Here we have a conic function. Conic means conic section means your elliptical section, your parabolic section, your hyperbolic section. Okay. Hello, I'm audible. Hello, hello,
Yeah, hello, ma'am.
hello, sir. Am I audible?
Yes, yes.
Okay. Okay, so conic section means your parabola, hyperbola, and elliptical section. So why we are called them as a conic? Because when you cut elliptical portions and parabolic or hyperbolic portion, cut their sections will look like a cone. That's why we call them as a conic section. In modeling, we can use conic shape fillet. Like they are not always a circular shape fillet. Everyone knows about the circular fillet, but we can use a conic fillet also, like elliptical shape, parabolic shape, and hyperbolic shape. There, we have a conic eccentricity value to identify um, their sections, like means elliptical sections or parabolic sections or a hyperbolic section. Actually, conic eccentricity value varies from 0.05 to 0.95. 0.05 to 0.95. See, if I'm creating here conic section, first starting point, end point, center, eccentricity point, and then apex point. If I'm creating, so with the help of this smart dimension, this row symbol indicate that conic eccentricity value. So we can set here conic eccentricity value. Conic eccentricity value varies from 0.05 to 0.95. So for parabola, conic eccentricity value is 0.5. For ellipse, value varies from 0.05 to 0.49, and then for hyperbola, value varies from 0.51 to 0.95. So we can change and we can set the view here. This is my parabola. If you want ellipse, see, you can set the value. You can give value between a 0.05 to 0.49. If you want a hyperbola, then you can give value between 0.51 to 0.95. For example, I'm giving here 0.9. So this is my hyperbolic shape. So also you can use a 3D fillet based on this value. Then here we have a Texas option. We can set the Texas also. I'm giving one reference place. Okay, here I want to draw Texas here. So your curve for the placement for location, then you can write down which word, which text you want here. Okay, you can give placement here. You can give text properties here. If you want to change the size, just untick on use document font. Click on font. From here, we can we can set. From here, we can set the values. For example, about 20. You can say in font style, font. Okay, and then okay, we can set. Texas. Then here we have a slot, elongated slot or slit slot we have here. So for a slot, the parameter type is slot length and the diameter or radius. So here we have a four type slot, straight slot, center point slot, 3 point slot, 3 point arc slot we have here. So the first one is a straight slot. Specify the first curvature center. See, you can see from here the input steps. Okay, first curvature center, second curvature, and specify the diameter value. And by double clicking also we can edit the parameters. We can edit input here. By double clicking we can edit input here. We can edit. Then the next one is a center point arc slot. See, center point arc slot, specify the center. Okay, then curvature center and then radius you can give. Then the third one is a 3 point arc slot. Specify 3 point arc slot. See, starting point of arc, end point, then direction, and then radius we can give. Then point arc slot from a center. This will center, start point, end point, and radius. So in this way, we can create a start angle and end angle. We can give. Then here we have a polygons. Polygon is we can give a number of sides. We can give number of sides. Basically, we have two types of polygons. Inscribe in circle or circumscribe about the circle. We can draw. We can select the type. Then specify the center. Specify here number of sides and okay. Here rotation angle, and here this one is circle diameter we can give. This imaginary reference circle diameter we can give here. And this is coordinate center coordinate point. This is polygon center coordinate point also we can give. Then here we have a fillet. Basically, fillet is surface finish operation. We can smooth the sharp edges because while handling they may harm us, so we can do surface finishing operations here. In sketch fillet, the parameter input type is of a radius. Also fillet will use for to reduce your stress concentration. Okay, stress concentration factor. Our stress concentration factor is inversely proportional to your radius. Okay, so this will use to distribute the stress. For example, on this point contact mode, there is a lot of chances to act more load, right? If you want to do stress distribution, just we can apply fillet and we can do stress distribution here. So for the stress concentration, to reduce the stress concentration, we will use a fillet also. So here we have a fillet, sketch fillet. Select the entities. You can select like this boss selection. If you want to apply at a time to four corner, you can use this box selection. See, in just right click. If you are you will show such lens selection and you want to do a box selection, just right click and click on box selection process. Here we have a selection tool, box selection. Okay, so just press the right click and move the mouse. In this way you can select entities. Just click here and move your mouse and you can select. Okay, so here, if you want to apply at a time to four corners, you can select like this, the same value. Then, if you want to apply only on this corner, so select the first entity, select second entity, yes, and we can specify the radius, fillet radius, and okay. Then here we have a chamfer. Chamfer also surface finishing operation. Basically, we have a three kinds types of chamfer. The first one is angle distance. Second one is distance, equal distance from the both side, and the last one variable or symmetric. Angle distance, symmetric chamfer, or symmetric chamfer. So three types of chamfer we can use. So, angle distance. Specify the angle and distance. Our standard chamfer angle is 45 degree. So, first one and specify second. Yes, we can apply. You can edit the input by just double clicking. Hmm. Then here, uh, then the next one is the distance. Distance. If you want to equal distance, you click on equal distance and specify the value. Then here, yes, if you want asymmetric, so just untick and see. You can give asymmetric value and we can apply. Here, then the next function is point. Point by clicking, we can give a point to x coordinate and y coordinate. Point coordinate we can give here. This is my, you can say a point using coordinate also. Then next we have here trim entities function. Trim entities means cutting entities functions we have here. See, five types of functions, five types of commands based on trim tool. We have power trim means your free trim, trim corner, make corner function we have here, trim away inside if you want to cut the inside a portion inside corners, then outside corner, and then trim entity we have here. And the functions like you can set like if you want to trim the entities, but if you want that entities in a construction form, then also you can use. Okay, if you have a construction geometry and you want to ignore while using power trim, so you can use this function also, ignore trimming of construction geometry. So then, see, we will see the trim functions, trim commands in detail. For example, and I'm creating one. See here, trim function. This is power trim means your free trim. Okay, same like in a paint we will use we are using in a paint. So this is power trim. Just click on your right button of the mouse, right key of the mouse, and just move your mouse. See. This is my free tip, power trims. Easily you can trim the entities. Okay, and so time. Um, then see. Now, while using this power trim, if you want to keep trimming entities as a construction geometry, so just click and see. Your trimming entities will convert to your construction geometry directly. Now, next. If you want to ignore trimming of your construction geometry while using this, see. So in such way, you can use these functions. Then here we have a corner. You can simply call it as a make corner or corner trim. So always select keeping entities. Always select your keeping entities, the entities you want to keep. So for example, this entity I want to keep or this entity I want to keep. Just select and see. You can make a corner like this. Then the next is trim away inside. So yes, the same rule, always select keeping entities. So trim away inside. Okay, then we can select. You want to trim outside entity, so select inside entity. Always select keeping entities. And if you want to use your trim tool, same as the AutoCAD, for intersection, you want to cut the intersection portion, you want to trim intersection portion or a single entity, intersected entity, you want to trim. So we can use trim to closest. This is very useful tool for us. Trim to closest. We can trim intersected portion with the help of this, and a single entity also we can trim as well. Okay, so this is my trim to closest. Then after that, here we have a extend entities tool. You can extend your geometry to next entity. We can extend. So this is my extend tool. Then here we have a yes, convert entities command. We can project entities from one plane to another. If you want to project your existing geometry on your new plane, so with the help of this convert entity, solute edge for a cylindrical portions, with the help of intersection curve, we can project. For example, I have a yes. Here I have a geometry part. Okay. Then I'm taking a sketch on this face. Okay. Then I want this edge as a geometry here. Okay. So with the help of this convert entity, go to convert entity, select that edge, and okay. We can create. Okay. This is the first use. Then the second use is, see, now yes, from the top view. Okay. This is my circle. Okay. Then you can from with the help of parallel.
Ma'am, your voice is not audible.
Hello. Yes.
Yes, ma'am, you are audible now.
Yes. So now, okay. Then see here. Now this is my geometry. I have drawn in on a front top plan, right? So I'm selecting a plane on front plane. So I want one intersection point here, or I want one reference point. So, or a reference entity. So you can project like this. So just click the entities, previous sketch entity, and see. Okay. So you can project, and you want to take a reference only. You can go to construction, and from here, if you want to draw the another geometry from that reference, then you can draw, because I want only here intersection point. Okay, so I want, if I want to draw the entities from that construction line, we can. So for the reference purpose, we can use convert entities. For a parallel entities or for intersection entities, we can use convert entity for taking a reference. Okay. Here we have a solute edges. If we have a cylindrical portion, okay, and if you want to take a reference, that time you can use solute edges. Select the portion and you can take a reference. See, you can take reference, you can delete the side that's not useful for us, and you can take a reference. So for taking a reference purpose, projection purpose, we can use convert entity function. Then after that, we have a offset tool. Offset tool here. Same. Now this is also very important offset tool. Offset means parallel entities. Offset means parallel entities. You can create parallel entities at particular distance. Concentric entities, parallel entities, you can create at particular distance. For example, mm, okay, so go to offset. I want to create a parallel entities. So select. Here we have a selections also. See, select. If you want to select a sketch, total sketch at a time, then you can select here select chain. Means select chains means you can select the connected entities at a time. Point connection method mode or a tangency connection mode. Okay, you can select from here. You want to reverse the direction, you can reverse. You can give here offset distance. Okay, then if you want a bidirectional offset parallel entities, use a bidirectional. Then if you want to close this geometry with the help of arc or line, just click on cap ends, arc. With the help of arc also you can close. Then with the help of line also you can close. If you want a base geometry in construction, you can. If you want a offset geometry in construction, you can. So this kinds of settings um, are available here. This is very useful for modeling. So we can create a offset functions. Then here we have a mirror. So basically replicate image we can create. Replicate images we can create. So go to mirror, entities to mirror, select your entities, select your reference, through which reference you want to create a mirror image. Select. If you want to delete this source object, this is my source object and this is my destination. Okay, target object. So if you want to delete your source object, just click on untick on copy and say you can use it like this also. Then here we have a linear function. For example, we have a plate by 300 by 300. Okay, then now I want to create a holes here. Simple holes for diameter 20, 20 mm, and the distance, counter distance from this plate to hole center. Okay, so I want to duplicate holes or pattern holes here. So in X or Y direction, so here we have a linear sketch pattern. Linear sketch pattern we have here. So we can create a duplicate images in particular format. So the first step is select entities to pattern. The entity which you want to pattern, select that entity here. Select entities to pattern. Okay, then x direction. So for example, this is my x direction here, x x direction. So here we have number of entities, number of features you want, number of instances, specify the number of instances you want, and then distance between them, instances spacing, instances spacing. You can flip the directions, you can change, reverse the direction, you can flip the direction. Then here you can change the angle orientations also, you can change, you can give value. Okay, then in say y direction, specify the number of instances. Okay, spacing, reflip the direction with the help of this. Okay, also you can give angle here. Okay, then instance test to skip functions we have here. If you want to skip any instances from here, so go to your instances to skipping, just click on that box and click on this pink dot. You can skip that instances. If you want again, just click. Okay, so with the help of that we can do, and we can pattern, we can create a duplicate. Then next is a polar, means circular pattern we have here. Mm, okay, if you want, just click. If you want this circle or this hole on this reference circle, okay, on this PCD circle, if you want a number of holes, so go to circular pattern again. Again, the first step is select entities to pattern, select the entities. Okay, then here this point means around which circumference you want to pattern. So select the center of that circumference. Around this circumference I want, so I'm selecting the center of this circumference. Then number of instances, here we have a input type like equal spacing, means complete crown method through the 360-degree equal spacing component we can create. Okay, or if you want to give manual angular spacing between the components, you can also give, or equal spacing also you can give. Same as a linear pattern, you can skip the instances also here. So like we can do circular pattern. Then after that, here we have functions like some modify functions we can call move entities, copy entities, rotate, scale, and stretch. So here we have a move entities. First of all, select your entities to move. Sorry for interference. Okay. Yes. First of all, select entities to move. Then here we can give, we can use the two method, from to selection and xy. Xy means you can give a coordinate, move point coordinate, move placement coordinate. You can give move means your displacement, from to means select the base point, means from that base point we can take a displacement distance. And here from to means you can give x coordinate for a displacement, y coordinate for displacement. You can give. Then here we have copy entities, select the entities, and then from to method, see. You can give a base point and you can give the placement, copy position to component. Then here xy, you can give x coordinate for creating a duplicate images, y coordinate for creating duplicate images. Then after that, here we have a rotate. We can rotate. Select the component, specify your center, first axis point. Okay, and you can give anti-clockwise direction rotation here. Here the angle is 0. From here I'm taking an angle by anticlockwise you can. Then after that, here we have a stretch entities. Sorry, scale entities we have here. Select the entities to scale. You can take the one origin point. From that origin point we can take a scale references. Okay, and you can give here scaling value. Then here we have a stretch. If I'm selecting a total object, then this stretch will work like a move. But for a stretch, our first portion is a rigid and another portion will be free. So see, go to stretch, select from which direction you want to stretch, select that direction, and now this is my rigid portion. Then from to or in with the help of xy coordinate method, just select and see, we can stretch the entities like this. Okay, so this is all about your sketching, draw tools and modify tools. Then now the time to give dimension. I want to give dimension. So here we are creating a drawing from the plane origin. From plane origin, we will create the drawing. So here, with the help of this smart dimension, here manual dimensions method also you can use, like a vertical, horizontal, chain dimension, baseline dimension, symmetric dimension. All you can use from here. But see, with the help of smart dimension also you can give all kinds of dimension. See, select and we can give. We can edit the dimension. You can rename the dimension from here. For example, this is my length 1. We can give, okay. Then we can rename the dimensions here. And we can rename. We can give the dimensions. If you want to give a rotate dimension, a line dimension, also you can give, see here. mm, See, rotate dimension. Just move your cursor. Okay, move your mouse to that directions. You can give rotate dimension. I'm not selecting any key. Okay, see, just move your direction of your mouse. Just you can give rotate dimension, horizontal dimension, or vertical dimension. Okay. Then see, radius of this diameter of this circle you can give. From here, the center coordinate distance you can give vertical or horizontal. Okay, and so in this way we have defined all the parameters from this plane origin. Now my sketch is showing a fully defined, fully constant, fully defined means all parameter like a geometrical or a dimensional parameter uh, we fulfill. Okay, so now the my sketch is fully defined. Okay, so black color shows your fully defined iso constant sketches. Now the second thing is, this is my dimensional constant. Then the second part is how we can apply geometrical constant to our drawings. Okay, so for example we have a object. So basically how we can activate our geometrical constant. Now, so I want to make this rectangle symmetrical with reference to this axis. Just for activating the geometrical constant, hold your control button, hold the control button and select the sides. First side, second side. Okay, I'm still holding a control button. Okay, with reference to this axis. So this is my geometrical constant. I want to apply symmetric. Just click. Okay, so you can make. Then I want to equal the radius of these two circles. So select first, select second with respect to that, and you can use the equal one. Okay, if you want to make a collinear or coincidence, just select the line, press the control button, hold control button, select the entities and make them collinear. If you want to make a concentric, select, hold the control button, select the circles and the so in this way we can use a geometrical constraint. Hold the control button, select the entities and apply. You want to give tangency, just see, so hold the control button, select the entities, and you can give a tangency. You want to give a horizontal alignment between these two circles. So hold the control button, select the first center, second center to that one, and click on horizontal. See, we can give, we can. So in this way, we can give a geometrical and dimensional constraint. Now, um, if you want to apply both the constraint here, see, I want to create this geometry by using geometrical and dimensional constraint. So first step, how we can start the drawing. Okay, from which reference you want to start the drawing. Okay, so this is the first reference I'm saying here because from this reference they will check all the dimensions. So I'm using your front plane. Okay, then um, here we have a 20 radius, sorry, diameter, and the radius is 30. Then here we have the other center 40 mm from this side, vertically and horizontally 85. So, so just 40 and from here to here, the distance is 85 here. Then, uh, then the radius is 30. We can use an arc or we can use a okay. Then here we have a slot. We can see diameter is 12 mm and the slot length from this to this is 40. So we have a slot function, automatic slot function. Straight slot we can use from this is the my center, then this one and give. So here you can edit. The slot length is 40. Okay, and the diameter is 12 mm. Okay, then we have other arc here for radius of 40 and this to this is 90. So And from here to this center distance is 90, 50 plus 40. Then here we have one, okay, line, tangent. Okay. Then again we have here one tangent. And here we have an arc of 50 degree. So here we have a 3-point arc. First point specify the first point, specify the second point, and okay. The radius of that arc is 50. So, okay. Okay. Now, you can trim. You can trim the portion you with the help of trim closest. Okay. We can trim like this. Intersected portion also we can trim. Now, here we have a tangency contact method, not a point contact like this. We have a tangency smooth contact portions. So we can give, just hold the control button, select the entities. Here we can give a tangency contact. Here, if you want a tangency contact, select the entities, give tangency, hold the control and give a tangency contact. Hold the control button, select the entities and use a tangency contact. Here also use the control button and use. Okay, here also use the control button and give a tangents. See. So by defining the geometrical and dimensional constraint, we can make a fully defined sketch. A black color is showing and you can see here notification fully defined. And after that, just exit your sketch. Just exit your sketch. Means by exiting the sketch, you will enter your part modeling, solid modeling workspace. Just exit sketch. Also, we have here exit sketch arrow and just click on exit sketch. Now, if you want to edit the sketch, so here this is my sketch. I want to edit this now. So just right click. Here we have a edit sketch function. Okay, you can edit also. You can also enter again. Okay, and now after exiting the sketch, you can apply 3D model parts here. For example, I'm using contours, portions, and see, we can make one simple product like this. So the first thing is create a geometry, and after that, you can apply. You can apply modeling function. Okay. So this is all about today's session. Okay, sir. Hello.
Yeah, okay, ma'am. If any
Yes.
participant have any question or doubt, he or she can post it in chat box, or you can raise hand. I'll unmute.
Go ahead.
We can wait 2-3 minutes, ma'am, so that if anyone
Yes,
has
yes,
any
yes,
question,
yes, yes.
he or she can
Yes, yes.
post it in chat box.
Hmm.
Till then, I request everyone to fill attendance come feedback form, which is posted in chat box here.
Okay, sir. Please ask the question.
Yeah, I
One
guess
questions. Yeah. Huh.
Kashvi Soni ma'am has one question.
Also, how to install the software? SolidWorks. Um, Yes, sir. Simulation is possible. Yes. Thermal simulation, static simulation is possible in SolidWorks.
Hello, hello.
Yes. Hello, sir.
Madam, this is Dr. Abhishek Soni.
Hmm.
Uh, I'm modeling, as we have seen that it can be possible. Wireframe modeling is, you have told us earlier in your
Hmm.
lecture. So, if we want to, madam, change somewhat parameters of the product that we are designing, that is
Hmm.
some sort of mechanical property, is it possible, madam? We can take the some other material in this type of software regarding
Yes, we
that.
can browse also. Okay. We can browse. Yes, and we can evaluate.
Okay, madam, we can put the constraint condition also in this.
Yes. Here we have means a UDF method, user defined features we can use with the help of the design table. Here we have
Ma'am,
design method.
meshing, we can do an we can put the load on the
Yes.
limited part and we can
Yes,
simulate
yes,
it
yes.
also.
Yes, see.
Okay.
Yes. For the simulation purpose, we can do meshing also, and we can apply
Yes, ma'am.
the load. Yes,
Ma'am,
yes.
as far as drafting is concerned regarding this designing that you've done,
Hmm.
so whenever we apply a finite element method,
Hmm.
students of PG they have means one of the paper and
Hmm.
they prepare the matrix. Madam is
Hmm.
this we can find print out the complete method of how after
Yes.
meshing that.
Means report, right?
Yes, ma'am. Report. Yes, ma'am.
Yes. Report we
Hard
can
copy.
create. Yes. Report we can create. We can download that report also. Same like a
Ma'am,
ANSYS.
so in that report means if we are taking a smaller part, so
Hmm.
means a rectangular matrix we are taking. So
Hmm.
the complete solution comes out in this report.
Yes. The complete
Means
solutions.
if we take the string that sorry stiffness constant and
Hmm.
how that is solving it means complete solution.
Yes, yes,
How
yes,
much load is
yes,
being taken and where the failure will occur.
yes. All the simulations, that's snaps. Also, you can see from that report.
Okay. Okay. Thank you,
Yes.
madam.
Yeah. Thank you, sir. The detailed report means overall detailed report you will get.
Yes, ma'am. Means the animation after animation is also
Hmm.
possible. I means and we can
Yes. I will show
generate the
you one.
report and see that
Yes,
after
one.
it's yes.
Yes, sir. I will show you one quick example also. Um, in SolidWorks. Give me a second.
Madam, nowadays CATIA is obsolete. Means nobody is using CATIA.
No, sir. CATIA also very useful software actually because in aerospace industry, most of, in automobile, like in domain wise, we can use domain wise also. Means CATIA we have a domain like BIW domain we have. If you want to do plastic designing with the help of CATIA, okay.
Okay.
If you want to do BIW designing, body structure white, interior, exterior trim portion, so CATIA is efficient software for that.
Ma'am, if we want to change the design of some means existing parameters, so which software would you suggest that we may use that software?
Existing
Means
software, existing parameter like a
ma'am, for means uh, I used to work with these softwares means 10 years back, ma'am. Now means my hand is now at means I have not worked for since last 10 to 12 years in this field.
hmm,
But
hmm,
earlier I used to work with SolidWorks, Solid S6, and
hmm,
AutoCAD. I have used and CATIA. So, madam,
hmm,
one project I undertook in which the
hmm,
drill bit
hmm,
the drill bit which is used in drilling machine
hmm,
my student was working on this. We tried to change the parameters means the flex angle and we were trying to make a new tool for working. So we were very much confused in CATIA. So
Hmm.
if such type of projects we take, then which software it is feasible, ma'am?
If you want to easy modeling functions, okay, so that time you can use a SolidWorks, sir. As
Ma'am,
compared to
SolidWorks 6 I have used, and
hmm,
KTF 1.5 at that time was coming, the new version.
hmm,
I think so. Just I remember, if I am wrong, then please forgive me. At that
hmm,
time, KTF was coming, and we tried
hmm,
to modify it. And in SolidWorks, yes, it was very good. Means we can import the
hmm,
design and we can
yes,
simulate
yes,
it.
yes,
We can do
yes,
the thermal design, thermal analysis also,
hmm, hmm, hmm,
and
hmm,
little bit fluid when by changing the material we
hmm,
can find out the which metal may be workable if
hmm.
load is exceeded.
So
My
see,
question
see,
was very
hmm,
precise, means ki if the parameters of regarding any existing design is changed. If I take the example that if I take cast iron instead of cast iron,
hmm,
I take white cast nodular cast iron for the,
hmm, hmm,
designing of piston,
hmm.
then what will be the means it is will be feasible with this type of software or with KTM, madam?
See, if you want to do detail simulation, hello.
Yes, ma'am. Ah,
Yes,
yes, ma'am.
if you want to do detailed study regarding the component material, okay, and if you
Yes,
want to
ma'am.
do detailed simulation, then you can use CE softwares like ANSYS.
Okay, ma'am. Ma'am,
Yes,
ANSYS 8.0 I have used. ANSYS and HyperWorks also I have used.
Hyperworks means your hypermesh, FE
Yes, ma'am.
modeling.
HyperMesh.
Yes, yes, yes.
Yes, ma'am.
So, with the help of hypermesh, you can do detailed modeling and mesh study, right? After that, you can upload that
Yes,
model
ma'am.
to ANSYS. And in ANSYS, you can do material study, fatigue analysis, thermal, static, modal, vibration analysis. So, detail, if you want to do detail analysis simulation, then the ANSYS is the best software for you. Or you can use Abacus Simulia also, sir.
Okay, 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 ma'am.
Yes,
Thank
yes,
you very
yes.
much.
Yes, Abacus Simulia is also best software for the simulation purpose. If you want to do detailed study and all,
Okay, ma'am. Okay,
we
thank you
have a
very
number
much.
of models. Yes,
Yes, ma'am. Okay.
yes, yes. Okay, yeah.
Ma'am, there is one FAQ in chat box. Can you provide a link to download a student version or free version of SolidWorks?
Yes, sir. I will share to you. Okay, I will share to you, sir.
Yeah, okay, okay, madam.
Yeah. Okay, sir. Yeah. Okay. Thanks for the attending the session. Thanks to everyone.
Okay, if there are no further questions, we can end this session.
Hmm. Okay.
Okay, ma'am. So thank you very much for your presentation. It was very informative, and I hope every participant must have learned many things from this session. So thank you very much, ma'am, again.
Yes. Thank you, sir. Thank you, sir. Thanks to everyone. Thank you.
A request to all participants to fill attendance come feedback form so that your attendance can be marked. I am now ending this meeting. I request you all to join tomorrow at 2 p.m. Thank you.